advertise my poster, which is out by the coffee station. So I was looking at the starburst-driven superwind in NBC 2146. We're taking sort of a multi-wavelength approach to look at the different phases of material in the wind. So I don't need to convince people at this conference that galactic winds are interesting, but I just wanted to make the point that they're really important for depositing energy into the surrounding ISM and in training material and removing it potentially from at least the star-forming regions in the center. This can have the effect of suppressing star formation, of course, and as well as potentially transforming the morphology of these systems. So when you talk about starburst-driven galactic winds, usually people talk about M82, but this is actually another really interesting nearby system. There's a limited number of these systems to study, so we have to look at all of them in as much detail as we can. So this one is more massive than M82, so it's more of a Milky Way analog in some respects. It has a really disturbed optical morphology, showing that it's had some sort of recent interaction or merger. And it has a lot of dust concentrated in the center. It's actually classified as a luminous infrared galaxy. So it has actually a high star formation rate. It's very dusty. It's very comparable in a lot of ways to what we see at higher redshift. So if you want to study galaxies at high redshift, then this might be a really interesting local analog. So we focused on this center region where, with the center 5 kiloparsecs, and we looked at a couple of different traces. We focused on the far infrared, looking at the C+ line emission, which we actually can trace the outflow through the disk center out into these cones opening out in all of this blue region. And we also mapped the center region in optical spectroscopy to look at shock tracers, and we found that the shocked regions agree very nicely with where we see this C+ in the wind. And taking this in comparison with other studies in the literature, this actually all agrees very nicely with where we see the hot gas in the X-rays and where we see molecular superbubbles here with these purple lines. So the key results in the poster, I won't go into detail. You should all take a look at my poster, come talk to me. But basically we try and put some constraints on the outflow physics, especially on the atomic gas in the wind. We talk about how this is a really great local analog for high redshift systems. And we talk about how this galaxy actually might be in the midst of undergoing a morphological transformation, because we see very disjoint kinematics between the gas and the stars in the system. We see this gas rotating in a nice disk, whereas the stars actually show very little evidence for rotation. So thank you very much for your time.